Greetings, ladies and gentlemen. Welcome to our presentation. I'm Chang-Hee, the leader of this group. Today we are going to conduct a final report presentation of our project, producing a full-leg military use robot. Before we start, let me introduce my teammates and the outlines of our presentation. There are Jimmy, Mike, Jeff, and Steve. Let me explain our different role and respective responsibilities. I'm the leader who coordinates our team, representing the team to communicate with the stakeholders and ensure the projects to stay on track. Also, we have Jimmy and Jeff as our incredible programmers. They are responsible for developing the control system, communication protocol, and the software for operating the spy robot. Besides, Steve and Mike are the two high-caliber hardware designers of our team. Their duty revolves around the design of the physical structure of the spy robot, selecting the component and supervision of the manufacturing process. Moving on to the presentation outline. Steve will first introduce the background and objective of the project, followed by production process of our spy robot, including the development process, the ESP32 web server setup, the control application, and the list of required resources, which will be discussed by Steve and Mike. Also, Mike and Jeff will show you our finding of the project details, namely the prototype specification, the prototype test result, a summary of the major feedback from the shareholders, and the future development plan. Next, Jimmy will talk about the challenges we encountered during the proposing process and the solution we came up with. A part of that, Jimmy will also conclude our presentation by presenting our group testimonial, as well as the reference list and the appendix. Now let me pass the time to Steve.
Hey, thanks, Brian. Before we move on the detail, let's have a quick look at project background. As we all know, their work is very dangerous. Many soldiers have fallen because for that they risk their life to fight for our safety. This is not what we want to see, and it is our utmost work to ensure the safety of the soldier. We want to help the soldier in our ways, and our mission is to develop a compact and agile spy robot that can navigate danger, please guard intelligence and support soldiers during combat operation. This four-leg machine will be safe tool for our army units, projecting them stealthy and respond plan from to improve their mission complete. As for the project objective, there are three aspects, namely stealthy mobility, information gathering, and reduce risk. This project is aimed at production for spy robot which can move swiftly and quickly, guard image and video proof, and reduce the risk of losing our soldiers' lives. Now let's have a look at the production position of our spiral board, there are the three aspects. The division for work will step being illustrated, the ESP32 web server setup, and the application used from controlling the robot. Here is the system overview of our spiral board. Arduino IDE was used as a complete to control the ESP32 module, and the module was connected with app grid by Unity. For the division of our works, for divide loop, the spiral board there was 3 places: remote, construction, mobile, application, and robot control. For roadmap construction, we designed the communication protocol with Arduino IDE. For robot control, we use ESP32 module with group control 12 motors for the spiral board. For the mobile communication, we developed a mobile app using Unity for giving commands to the spiral board. On the mobile device for now, we'll talk about the hardware, software setup, and resources needed, and the project specification of the project. Let me pass the time to Mike.
Okay, thanks. But before we start the course of this robot, I would like to have a brief introduction on one of the most important parts of our robot, the ESP32 chip. First is crucial of providing the function in the project, the ESP32 Wi-Fi module and the camera module. The camera is for recording video and images, and Wi-Fi is for transmission detail. Then we need the Arduino IDE as compiler, which is a computer program that translates computer code written in programming language into another programming language, so that we could code ESP32 in Arduino IDE. I'm going to show you some of the codes of the Wi-Fi modules to work. The above the codes are for launching the access code, the points, so we can connect this IP address. As what I have just the ESP32 modules can transform video days is Wi-Fi, and we thought and if could release source the time to log in on the IP of the spiral board. Therefore, we develop an app by use Unity, which is a command speeding language to control the robot and receive the video data for the model. Here is the list of the resource we use to create the spiral board, including an ESP32 modules to 18650 batteries and an ultra portable sensor. After that, we need to move on the discussion project details. There are 4 main upon the test resource field for the sensor and feature develop pass. Let me pass the task project.
Thanks, man. And this is the prototype of our spy robot. Since the robot was supposed to be used as a spy, we aimed to make the robot tiny and agile. For the specifications, the robot is 16 cm long, 11 cm wide, 9 cm tall, and weighs 400 grams. Fiberglass and PLA plastic was chosen for the robot materials so that the robot was light and durable. We also add many functions to our spy robot, which allow the robot to gather enemy information. Moreover, the robots were heat resistant, so it's included to be operated in high temperature conditions. Right now, I will talk about the test results of our spy robot. There were 3 tests conducted in total. In the first test, we tested the robot Wi-Fi connections. The performance was satisfactory, and the Wi-Fi connections was stable within a 15-meter range. But the robot experienced noticeable latency and disconnection issue beyond that range after making server adjustment, such as upgrading the Wi-Fi chipset within the ESP32 module. We were able to control the robot within a 25-meter range without certain disconnections in the second test. And there was an increase of 66% in the controllable distance. However, there was room of improvement in the camera quality and video stability. In the final test, we addressed all the previous issues, including the robot's Wi-Fi connections, movement, and video quality, so that our success criteria were met. The video stability was greatly improved with a new mounting system, and the robot was operated without any problems or failure within a 30-meter range. To gather feedback from multiple stakeholders, we created a questionnaire survey, and this diagram summarizes the feedback of the first questions. Around 2/3 of the respondents agreed that our robot could transmit quality photos and videos, but the remaining respondents did not share the view. One of the prominent opinions was that the robot was too wobbly while it's moving. To address that issue, we plan to add sharp accessories to our spy robot in the future. Then, this bar chart shows the results of question 2. A majority of the respondents agreed that our spy robot has an easy-to-use interface. Some interviewees thought that we should add more instruction on how to use our mobile app. First, we will include a tutorial into the apps and help the user to know how to control the robot. Moving on to the results of question 3. 10 out of 15 of respondents comment that our robot could support long-range transmission without latency. But the rest held the opposite stance. We believe the negative response were due to either obstacles blocking the connections or a transmission delay. To tackle with this problem, we plan to update the signal transmitter of the robot. For now, Jimmy will talk about the future development and make conclusion. Let me pass the time to Jimmy.
Thanks, Jeff. And based on the feedback, apart from the plans we just mentioned in the previous slides, we plan to redevelop the design of the robot and upgrade the functionalities to better cater for the needs of the military and security sectors. We understand there are scenarios where maintenance and more technician support for the robot are needed. For example, the spy robot is not functioning properly during the operation in the dark environment without night vision. And the camera is unstable while the spy robot is moving. And therefore, we will carry out more upgrades and modifications for the spy robot in the future. The robot will be equipped with a night vision camera, and new materials will be explored for the robot to make less noises from the joints of the spy robot's legs and the body. And while we were working on the spy robot, we encountered a couple of challenges. First, we struggled a lot about the external design for the robot at the initial stage of our project. We sought help from the trade teacher, Mr. Chu, to tackle the challenges by using fiberglass for the robot's structure. Apart from that, we also faced an issue regarding the robot's control program, which kept crashing. We resolved this by searching for online resources and debugged the codes. And furthermore, we lacked internal communication, which led to inconsistency of our opinions and inefficiency of the collective works. By completing this project, we understood that efficiency, communication, and teamwork was crucial in navigating the various challenges. We then organized online meetings to have detailed discussions to reach a consensus. The problem seemed less challenging as we worked together. And during the past few months, we learned a lot from completing this project. We learned how to produce a spy robot from scratch, how to write a final report to present our creation, and what we need to prepare for the project presentation. These kinds of memorable experience will become our soft skills. No matter whether this project turned out to be a success or not, we are confident to say we came through a meaningful, productive, and impactful period of work. Although we encountered a number of problems, we do not give up, and we made our best efforts to make it through. At last, we want to say teamwork and skill is the most important thing in this project. Understanding our team members' questions and providing support for them is essential to optimize everyone's working efficiency. In fact, it's a must to every shareholders in this project. Thanks for our teachers' support and the questionnaires respondents, so we can exploit our full potential to create our spy robot. And this is the list of references we used for our project. And here is Appendix 1 showing our sample questionnaire used in our project. And this is Appendix 2 that showing the average scores of the statements of the questionnaire with a summary bar chart. And before the end of our presentation, we would like to give a big thanks to our English teacher, Mr. Pang. He spent a lot of time leading us to complete this project. Thank you for his patience and guidance. And that's the end of our final presentation. Thank you for listening. Do you have any questions?